Damn. Yeah.
Hello everybody, welcome to our channel. Today I will be teaching you guys Math Test SSM Form 4 Chapter 8, which is Measure of Dispersions of Ungrouped Data. In this chapter, we will learn about dispersion and measure of dispersion. 8.1 Dispersion. The distribution of the data are different. To understand the distribution of data, the difference between the largest value and the smaller value is taken into consideration. If the difference between the value is large, it indicates that the data is widely dispersed and vice versa. Here are the examples. Question A. As you can see, the table having 8 values. Let's find out the largest value and smaller value. After that, calculate a difference between the two values. Lastly, we got 74. Now, question B. For this dot plot, we also do the same way, which is find out their longest value and shortest value. And then calculate a difference between the two values. And we got the answer, which is 2.3. Now then, compare and interpret the distribution of two sets of data based on a stem and leaf plot. Let's see the example. Months of November and months of December. And we must answer these three questions. Before we do these three questions, let us draw the stem and leaf plot. First, write the month in the top of the line and list out all the first digit then having from the months of these 2 months, which is 3, 4, 5, 6, and 7. And then list out the second digit from all of the months of November. After that, same way to the December. Now we finish the stem and leaf plot. Now we can go back to our question. The first question. Which set of data shows whether dispersion? Justify your answer. The answer is the dispersion in November is largest because it has a larger difference in value. Second question. Which month has a higher difference in value? The answer is November has a highest difference in value. That is 4. Last question. Between the months of November and December, which month is better? And we can write, we found that the months in December is better because there are more highest marks compared to November. Now, 8.2 Measures of distribution. Measure of distribution are important measurements in statistics. The measurements of distribution give us an idea of how the values of a set of data are scattered. Measures of distribution of a set of data are quantitative measures such as range, interquartile range, variance, and standard deviation. Now then, determine the range from the ungrouped data and frequency table. The formula of range is largest value minus smaller value. Let's see the example. Question 8. First, we find out the largest value and smaller value to calculate the range, which is 78. Question B. In this table, we must ignore the number of students and find out the largest value and smaller value from the score to calculate the range. And the answer will be 6 minus 3 equal to 3. After that, the part of determine the interquartile range of a set of ungrouped data. Let us go through the example. First, we must find out the middle of the value, which is 47. Now, we will see that the left side of middle have 4 value and the right side also have 4 value. And these two sides, we will find out the middle of each side, Q1 for the left side and Q3 for the right side. To calculate Q1 and Q3, we must divide the two values in 2 to find out the Q1 and Q3. Lastly, we can calculate the interquartile range with using the formula Q3 minus Q1, and the answer is 33.5. Now then, determine the interquartile range of the frequency table. Let's see the example. Before we find out the Q1 and Q3, we must list out the cumulative frequency. 0 plus 4 equal to 4, 4 plus 7 equal to 11, and so on. And now we can find out the Q1 and Q3. For Q1, we will use the formula to find out the position of the Q1 value, which is 1/4 multiplied 16, and the position is 4th number. After that, we can find the Q1 for the cumulative frequency with the position, and the Q1 is 5. Besides that, Q3 is same like Q1, need to find out the position, but the formula have a big change from the Q1. The formula is 3/4 multiplied 16, and the position is 12th number. Same way, find out the value with the position, and the Q3 is 7. At last, we can calculate the interquartile range with 7 minus 5 equal to 2. Now is the part of determine the variance and standard deviation. This part we will learn about the formula of mean, variance, and standard deviation. To let everyone easily to understand, we'll go through an example. First, we calculate mean with the formula. Then, mean is 5.6. After that, we can calculate the variance with the formula. Then, variance is 4.64. And last, we can calculate the standard deviation, square root the variance. Finally, we got the answer, which is 2.50. After that, the part of determine the variance and standard deviation of the frequency table. Let's see the example. Same way, first calculate mean with the formula, but the formula will have a big change, which is the value must multiply with the number of students. And then we got the answer, which is 1.73. After that, calculate variance, same thing, with mean, which is multiply the number of students, and the answer is 0.6. At last, square root the variance to get standard deviation, which is 0.77. Furthermore, construct a box plot. Here the example. To draw a box plot, we need to list out the minimum value, maximum value, Q1, Q3, and interquartile range from the data given. Here the information that we need to list out. After that, we can draw the box plot with using the information that I list out. Now then, the effect of the measure of dispersion when each data is changed by adding or subtracting a construct. Here we can see the example. When each value of a set of data is added by 2, now let us calculate both score range before and after. And we will notice that both of the score range is same value. That means that when each value of a set of data is added by a constant, the measure of dispersion remain unchanged. Next, the effect on the measure of dispersion when each value of a set of number is multiplied or divided by a constant. An example, when each value of a set of number is multiplied by 2. Okay, same way, calculate the both score range before and after. And we will see that the both of the score range is not same. That means that when each value of a set of number is multiplied by a constant, the measure of dispersion will change. After that, the effect on the measure of dispersion when the value add or remove is an outlier. Let's see the example. Okay, when an outlier 9 is adding, same way, calculate both score range before and after. And both of the score range is not same. That means that the measure of dispersion of the new set of data become larger compared to the measure of dispersion of the original set of data when an outlier is added. Now, the part of calculate the standard deviation of the set of data. Hence, calculate the new standard deviation when. Let's go through the example. The data is 3, 6, 7, 9, 10, 11. Before we do question A, we calculate the mean and standard deviation. For mean is 7.66 and standard deviation is 2.7. After that, we can go back to the question A. 3 is removed, and the set of data will be 6, 7, 9, 10, 11. Now we use this set of data to calculate mean and standard deviation. And the mean is 8.6 and standard deviation is 1.85. And we notice that the mean and standard deviation is not same like the previous one. Next question B. 13 is added and the set of data will be 3, 6, 7, 9, 10, 11, 13. Now use this new set of data to calculate the mean and standard deviation. And we got mean is 8.42 and standard deviation is 3.13. It is same situation like question A, which is the mean and standard deviation is not same like the original one. Now the last part of this chapter, which is compare and interpret two or more sets of ungrouped data based on the appropriate measure of dispersion. To let everyone easily to understand, I will go through an example. Calculate the mean and the standard deviation from the time taken to complete the job. Hence, determine which factories employees are more efficient to complete the job. Justify your answer. Now, as we can see the table has two factories. That means that we need to calculate mean and standard deviation to both factory. First, we calculate the factory X, and the mean is 7, and standard deviation is 0.663. After that, we can calculate the factory Y, and we got mean is 7.4. And standard deviation is 0.66. After we finish our calculations, we need to justify our answer, and we can write the employees in factory X are more efficient because its standard deviation is smaller.